Hello everyone and welcome back. In this lecture we'll continue our discussion on decision trees and random forests. Let's start by quickly building a random forest classifier model and do some evaluation on our previous data set. Okay, let's start by instantiating our model, random forest classifier, and we'll pass the number of estimators attribute n underscore estimators, and we'll set it to be 150. So let's save this in a variable called random forest underscore model 2. Now that we have instantiated our model, let's call the fit method and train our model with the training datasets xtrain and ytrain. So ref model2 dot fit, and then we'll pass our xtrain and ytrain datasets. Let's run this. So here are the default values used for the various parameters, and you can check out what these are on the documentation. Now that we have trained our model, let's make predictions by using the testing dataset xtest, and we'll save the result in a variable called prediction. Let me call it rf prediction for random forest prediction, and that will be equal to our random forest model 2, and we'll call the predict method on it and pass our xtest dataset. Now we can make some evaluations by calling the confusion matrix and classification reports. So let's print them out. Let's start by printing the confusion matrix. We'll pass our y-test and random forest prediction that we just calculated. Run this, and next let's print out the classification report, and we'll pass again our y-test and random forest prediction. Okay, so let's start by looking at the classification report. We see that we have an average accuracy of 100% for precision, 100% for recall, and 100% for F1 score. And using our random forest classifier model, we had a 99% accuracy. And if you check out each of the individual rows here, when good loans is equal to yes, the precision is 99%, whereas the recall and F1 score are 100%. And when our good loan value is equal to no, we had 100% precision and 97% for recall and 99% for F1 score. Our previous model had about 97 and 98%, right? So let me print out the classification report of our previous decision tree classifier model. Print classification report. So if we pass our y-test and prediction 2, so that's the classification report of our decision tree classifier model, right? There isn't much difference because 99% average accuracy and 100%, they are very close, right? Even if you take individual rows for good loan yes and good loans no, you don't see much difference because you have already achieved a very high accuracy. And here, if you look at the confusion matrix, we only had 13 misclassified data points, right? Whereas our previous model had, I believe, 21. If we print out the confusion matrix, let me add another cell here and print out confusion matrix and pass y-test prediction 2. So if we compare those two, we had 12 plus 9, about 21 misclassified data points, whereas the random forest classifier model only had 13 misclassified data points. Okay, so 13 versus 21. Still, our model did better. Our random forest classifier model did better than the decision tree classifier model. You might not see a much significant difference, but usually random forest classifier models do better than decision tree classifier models, and that's especially true when you have a larger data set. For our last example, what we'll do is drop some of the features from our loans dataset. So let me call the loans.head method on our loans dataset. So we used about 23 of these columns as our features, and we used the good loans column as our target. What we'll do for this last example is drop some of these features. We'll drop a few of these features, maybe 10 or 12 of these features, and we'll only consider the remaining features, the remaining columns as our features, and as usual we'll use the good loans column as our target, and we'll build a decision tree classifier model based on those specific features. And next we'll build a random forest classifier model using those features, and we'll compare them and see. So let's drop the following columns. We'll drop the bad loans and good loans columns as usual, and in addition we'll also drop these columns. I just copied this to save us some time. So annual increase, DTI, all these columns, I just grabbed them from our loans dataset. So we'll drop all these columns, and we'll pass axis is equal to 1 to show that we are dropping the columns, and we'll use the remaining columns as our feature. Okay, and for our target we'll use the good loans column as our target. So we'll save it in a variable y, loans, then good underscore loans. Next, let's check out the shape of our x and y, our features and target x and y. Print x.shape and y.shape. Run it. So for our x, for our features, we'll use 11 columns or 11 features. We have dropped about 12 of the previous features we have used. In the previous lecture, we used 23 features. Now we'll only consider 11 features. Okay, so the shape of our features dataset is 9516 rows by 11 columns. So number of rows stays the same, only number of columns changes since we have dropped all these columns. And y.shape is 9516. Next, we'll use the train test split method to split our dataset into training and testing datasets, and we'll save them in variables xtrain, xtest, ytrain, and ytest. Xtrain, xtest, ytrain, and ytest. That will be equal to train test split, and we'll pass our features and target x and y datasets, and for test size we'll use 30%. Again, you can leave it if you want to use the default value for the test size, and we'll pass a random state of 124. If you want to get the same result as me, you can use the same random state, or else you can use any other random state. Now let's check out the shape of our xtrain dataset, xtest dataset, and ytrain and ytest datasets. Xtrain.shape, xtest.shape. So we are using 70% of our dataset for training and 30% for testing. That's what you see here. Xtrain is 6661, which is 70% of 9560. And our testing dataset Xtest is 30% of 9560. Similarly, if you print out the shape of Ytrain and Ytest, you will see the same 70-30 division. 70% for training and 30% for testing. Next, let's instantiate our decision tree classifier model, and we'll save it in a variable called model3 since it's our third decision tree classifier model. So we'll call the decision tree classifier. Once we instantiate our model, we'll train our model by using the training datasets Xtrain and Ytrain. So model3.fit, and we'll pass Xtrain and Ytrain. And those are the default values for our decision tree classifier model. Next, we can predict by using the Xtest dataset, and we'll save our prediction in a variable called prediction3. We do that by calling the predict method on our model, on our decision tree classifier model. So let's pass Xtest. Now we are ready for evaluation. We'll call the confusion matrix and classification reports to evaluate our model. So let's print out the confusion matrix, and we'll pass Ytest and prediction3. Let's run this. So this is the confusion matrix. About 145 plus 167 data points are misclassified as false positive or false negatives. Right? That's a big number compared to the previous results. Next, let's print out the classification report. We'll pass Ytest and prediction3. And here is our classification report. We have an average precision of 89%, and for recall and F1 scores, we have 89% also. And if you check the individual rows, when good loans is equal to yes, we have about 93-94% precision, recall, and F1 scores. So our model does good when good loans is yes, but it doesn't do as good when the value is no. Here you see a precision score, a precision of 65%, recall of 68%, and F1 score of 67%. Okay, and from the confusion matrix, we saw how many of them were misclassified as false positives or false negatives, which is 167 plus 145. Next, let's build out a random forest classifier model and compare our results to our decision tree classifier model. Let's start by instantiating the random forest classifier model, random forest classifier, and we'll pass the n estimators attribute and set it to 150. I'll save our model in a variable called random forest underscore model3. Now let's call the fit method on our model to train our model by using the Xtrain and Ytrain datasets, Xtrain and Ytrain. Now that we have trained our model, let's call the predict method and pass the Xtest dataset to make predictions. And we'll save our variables in our result in a variable called random forest prediction3, and that will be equal to random forest underscore our model3 dot predict, and then pass our X-test dataset. Let's run this. Now let's do some evaluation by printing out the confusion matrix and classification report. So print, let's start by printing the confusion matrix. We'll pass y-test and then random forest prediction 3 that we just calculated. Run it, and let me print out the classification report, and we'll discuss after that. Let's pass y-test and random forest prediction 3. Run it also. So let's check out the classification report. We have an overall average precision of 91%. Recall and F1 score are also 91%. Our previous decision tree classifier model had an average accuracy of 89% throughout, right? And if you consider the individual rows, we have a 93%, 97%, and 95% accuracy for precision, recall, and F1 scores. And when good loans is equal to no, we have about 79%, 60, and 68%. So it depends on what we are actually looking at, whether it's precision score or recall or F1 score. Okay, and if we check out the confusion matrix, about 182 plus 73 of them are misclassified as either false positives or false negatives. The value was a bit higher with our decision tree classifier model, which was 167 plus 145. That's what, 112, I believe. Whereas with our random forest classifier, it's less than 260, right? You see the difference. So we see here that random forest usually does better than our decision tree classifier models. And the larger your data set, it becomes more and more visible. So that's what I have for decision trees and random forest. Thank you everyone, and see you at the next lecture.